go with the multiplication piece of it. So we'll take, again, look at a multiplication problem, and then we're going to go into simplifying when multiple operations could happen. Then also going to work on solving matrices if we have an unknown matrices. So kind of like solving equations, but solving matrix. So let's look at these two matrices, and we're going to go ahead and multiply them together. Let's go with -2, 0, 3, 1, 4, -1. We're going to take that times 2, -2, 3, 0, 4, and 1. So we got two matrices that we're going to multiply together. Again, just review. Those of you that have been gone or were gone yesterday, this lesson is uploaded onto Schoology. So if you want to take a look at that, you can certainly take a look at that. It's in the Tuesday folder of Schoology. Remember, when we're doing these, first thing you have to check is you have to make sure that you can multiply them. And the way we determine if you can multiply them or not is you look at the dimensions. That's a 2 by 3. This is a 3 by 2. Number of rows by number of columns. Rows and columns. If the middle two, if these are the same, that means you can multiply them. The resulting matrices then that you're going to get out of it is the two ends. So we're going to have a 2 by 2 matrix out of this. So we know we're going to have this 2 by 2 thing. So I've got kind of these spaces that need to be filled in and covered for. We multiply rows with columns when we're doing these. So I'm going to take -2, the first element of this one, times the first element of that one. So it's -2 times 2, which is -4. Then we just kind of advance down, over and down, and you multiply those together. 0 times -2 is 0, so we're going to put +0. 3 times 3 is 9, so we'll put +9. So that's going to give me that element, and if I want to go now right away to create my solution, -4 plus 0 plus 9 is 5. I know that I'm going to have a 5 in that spot. Now we're going to leave the row the same, but we're going to change the column. So now my solutions are going to go in row 1, column 2. So again, we do the multiplication. -2 times 0 is -2. We just, again, over and down. 0 and 0, 0 and anything is 0, so it's +0. And then 3 times 1 plus 3. And I just did the last one. I didn't move them over as such. Add those together, we get a 3 there. Now I can't do any more columns, so that I need to move my row down this way and column over this way. And I'm going to take these things out of there for the rest of the time, because that's hard for you guys to do. I mean, you guys can't do that on your sheet of paper. You've got to kind of think about what you're doing here. So we've got the first elements. 1 times 2 is 2. 4 times -2 is -8. -1 times 3 is -3. -9 is what that is. Okay. And then the last one is the second row, second column. 1 times 0 is 0. 4 times 4 is 16. 1 times -1 is -1. Add those together, you get 15. That then is your resulting matrix by multiplying those together. And again, it's all about rows and columns when you're doing these. Always make sure when you're doing these that you can multiply them together first. The resulting matrix comes from that outside piece then. Okay. So that was day 2 of matrix, a little bit of a day 2 for matrix. If you have day 2 done, please turn that in. If you don't have it done, get it done. Today what we're going to do then is we're just going to kind of look at addition and subtraction again first. But now, and scalar multiplication. But now we're going to do maybe multiple operations within it. So let's say that we have the matrix -2 and 4. And I'm going to subtract from that the scalar 3 and the matrix 2, 4. So we've got multiple things going on here. We're not just adding them. We're not just subtracting them. We're doing multiple things. And when you're doing these, you've got to think about these just as if they were like X's and Y's. And what would you do first? If you've got parentheses, order of operations says that we do parentheses first. So that means that the first thing we have to do is we have to figure out what we have inside of this parentheses here. And we need to fix that. So I'm not doing anything with the matrix 2, 4. I'm leaving that alone. Same thing with the minus symbol. However, I'm scaling the matrix 2, 4, scaling it up by 3. So when we did that, we said that we took each element times 3. So now 3 with the matrix 2, 4, that's going to become the matrix 6, 12. 3 times 2 is 6, 3 times 4 is 12. Now we look to see if we can subtract them. Remember, when you subtract them, they have to be the same exact dimensions. That doesn't change. Yes, most of the time you just look at it. You don't need to write it's 2 by 1, it's 2 by 1. I get that. But in order to subtract them, and there's going to be a couple today that you might be able to do the first operation, but then you can't do the second one because they're not the same dimensions anymore, so we couldn't. This case, we can. So since we can do that, we're going to go ahead and do it, and it's just -2 minus 6. First element minus the first element. And then we do second element minus the second element. So 4 minus 12 is -8, -8. That is our resulting matrix with these. And you're done. But it comes about being able to and wanting to follow that order of operations when you're doing these. Okay, so there might be scalar multiplication that you have to do. There are going to be some today where maybe you just have 3 things, say -3, 4, and 10. And then we're going to subtract from that inside parentheses 5, 2, 3 minus -2, 6, and 8. Okay, so again, we've got multiple things going on, but always keeping in mind we have to deal with this part first because it's inside parentheses. So the first one, again, we leave it alone, -3, 4, and 10, minus, now I look at the matrix and first make sure I can do it. I can do it. 5 minus -2, 7. 2 minus 6, 3 minus 8, it's -5. So now I've got these 2 matrices, now I can subtract them to get my new matrix. -3 minus 7, -10, 4 minus -4 is 8, 10 minus -5 is 15. So there again is the resulting matrix, and you're done. So it's with those multiple operations. Just make sure you do what's inside parentheses first. If you have scalar multiplication, make sure you do the scalar multiplication before you try to add them together. Add them together later. Second part of today then is to solve matrix equations. So let's say that we have the matrix 19, 4, and that's going to equal 10, 12, plus some matrix Y. So we have to figure out what matrix is going to make this true. Here's how I think of these. If I had 4 equals 2 plus Y. If I had that. That's not what this is. This is just a completely different thing. But it's an equation, right? How would I solve this equation? I would subtract 2 from each side, right? And we get Y is equal to 2. That's the same exact thing you do up here. We go to where our Y is, and we are going to subtract the matrix 10, 12 from both sides. So our new matrix then is going to be 19 minus 10, which is 9, and 4 minus 12, which is negative 8. That's what our Y matrix is going to be. Logically, right? Couldn't you think about it in your head as well? And that's honestly, you could do it like this. Mathematically, that's how you do it. But if you logically think about it, what values do I have to put in here? 10 plus what is 19? 9. 12 plus what is 4? Negative 8. You can think about it in your mind as well. Mathematically, yeah, that's how you have to do it. But if you can do it in your head, more power to you. Where do they get a little bit more confusing? Well, kinda. If you have something like 2y is equal to 14, 8, and 10. So 2 times some matrix is going to give you this matrix. This is where I do it all in my head. I have to figure out what this matrix is going to be so that I get 14. There's no division bar in these. 8 and 10. 2 times what is 14? 7. 2 times what is 8? 2 times what is 10? It's not rocket science. I don't think. No. Some math is rocket science. I don't think this is one of them. Maybe it is. I don't know. I'm not that smart. Okay. Last one. And then I'll give you your assignment for today. Let's go with the matrix 13, negative 19, negative 29, and negative 13. I ran out of space. That's going to equal 2 times some matrix plus negative 5, negative 5, negative 9, and negative 5. So now we've kind of got this multiple things going on to solve this matrix. We'll do it together. Again, think about it as being just numbers. 4 is equal to 2a plus 7. You're going to subtract 7 first, right? To solve this, you would subtract 7. Well, that's what you're going to do. But it's not a 7, it's a matrix. So you're going to subtract off negative 5, negative 5, negative 9, and negative 5 from both sides. Lots of negatives in here. So you got to be careful. 13 minus negative 5. 18. Negative 19 minus negative 5. Ha. There you go. Yeah, go ahead. Shh. Yes. So 13 minus negative 5 would be the same as 13 plus 5. Okay. It would be negative 14 would be the next one. Negative 9 minus negative 9. Negative 20. And negative 13 minus negative 5. Negative 8. That's equal to 2 times some matrix, right? 2 times what is 18? 9. 2 times 9 is 18. 2 times what is negative 14? Does everybody see how I'm doing it? 2 times what is negative 20? 2 times what is negative 8? That right there is your solution. That's matrix equations. Okay? That is the last lesson